Palo Alto studio connecting Silicon Valley and Wall Street.
I'm John Furrier, co-chief here with Dave Vellante, my co-host.
Welcome back to theCUBE's live coverage here in Paris, France for the RAISE Summit. This is the day zero event, Machina. This is the focus of physical AI and robotics. As the market expands and the TAM expands, a lot of use cases, a lot of broad use cases, but also heavy deep tech. Our next guest, John Hurst, co-founder and chief robot officer at Agility Robotics. I love that title, I just can't tell you how much I love that. Jonathan, thanks for coming on theCUBE.
Yeah, thank you for having me.
You guys are doing so much work. I love the chief robot officer because my first impression was, oh, CTO.
Yeah.
But you guys have a unique structure.
Yeah.
Talk about the facets of what it takes to build these robots and what your role is.
Sure, so I mean, robotics is so broad, right? We have to really be experts at hardware, experts on software and control, experts in the electronics. It's really huge. And we do have a fantastic chief technology officer, Pras Velikapudi, and he's very operational and running the software organization and everything else. My role is a little bit more like a chief scientist and really looking a few steps ahead, hardware focused. I'm a very hardware focused person on actuators and machine. And like industrial design and the vision of what do our robots be and how do they look in the world.
First question I want to ask is, a lot's changed in the past 18, 12 months. What, in your opinion, has been the biggest change in this industry? Because this event is just the precursor, preamble, the wave coming next year, commercialization wave.
I mean, the biggest change is just sort of the awakening that everybody has, that this is real right now. And yes, the technology is improving, but it's sort of a self-fulfilling prophecy in that there's now investment, and now there's thousands or tens of thousands of engineers focused on it, new tools being created, whole supply chains being created. And as we get out there and deploy the robot and kind of learn those hard lessons of what does it take to deploy, we get to be very pragmatic in how we do that.
I want to get into Agility Robotics, but let's stay on this kind of philosophical trend for a minute.
Yeah.
I'm old enough to remember when AI was hot in the 80s and early 90s.
Right.
AI, robotics have been this, I won't say cottage industry, but it's been a nerd fest.
Yeah.
Very deep tech.
Yeah.
Just doing a lot of great engineering work, but the acceleration wasn't there, the compute wasn't there. Over the past couple of years, it's been really fun to see AI explode because the underlying infrastructure and the chips and the technology, the hardware.
Everything's getting to this inflection point.
It feels like the systems level componentry, the software at the kernel level, low level coding is all kind of just moving so fast, almost like a breakout.
Yeah, well it is, because like I said, everybody's building the tools now. It's so much easier to build a robot than it was 20 years ago. 20 years ago you had to build everything yourself. Now there's a lot of things to build it with.
Talk about Agility Robotics. What's your current business for the folks that don't know much about what's happening there? Give us a quick overview.
Well, I mean, Agility Robotics, we've been in business now for 10 years. And this company spun out of my research lab at the university, and we started selling research robots, and we kind of went through phases of the company. First R&D, and then it was sort of proof of concept stage. We started deploying the robot Digit that we imagined as engineers is going to be a general purpose machine to do useful things. And you really run into the real world of what do the companies actually need, what are the actual constraints on doing something that's useful for them, and that's allowed us to really figure out, when we commercially deploy, what is needed. And that's what's in Digit V5, is kind of this full functional safety and the fast charge battery and all of these features that mean the robot can do the work, and not only can it do the task, but it can do it in a way that can be insurance companies can cover, and can provide an ROI for the customer, and meets all of the cloud compute and the IT infrastructure needs, and like real execution challenges.
One of the things that I've been most excited about this year has been the agility piece. A lot of different use cases. First one was augmenting manufacturing.
Yeah.
Very strong use case because they have factories, they have old systems, IoT systems that are hard to just rip out.
Right.
So you can have a good augmentation, but then acceleration. What are you seeing as the key use cases right now that are locking in? What are the first wave of adoption look like?
I mean, the perfect use cases are the ones that are process automated, but they still have people doing them because there's enough variety in it, it's hard to automate with a specialized system. And so having something like Digit to just walk in and be able to do that first human workflow is really worthwhile. So it's useful, I think it's a valid question to say, okay, yes, we want robots in human spaces, why are we building humanoids? Well, the first use case that's been really a good match for us is pick up large bins, because you need 2 arms to do that. Lift them up to the top shelves in narrow spaces, because you need to be balancing to do that, and having 2 legs is the best way to be balancing. So picking up bins from somewhere and putting them somewhere else, from an autonomous mobile robot to a conveyor belt, from a shelving unit to a stack, depalletizing, all of those kinds of classes of fairly general workflows are a really good entry point into the market for a humanoid robot. And this is just the first step.
I've done some stories on Amazon's warehouses. There's all the big manufacturing and fulfillment centers have some robotics.
Yeah.
They've been doing it for years.
A lot, and growing, yeah.
And growing, but now you're starting to see that move down in the market to the mainstream.
Well, the real difference is this. There's these eras of robotics, and we started with the bolt-down robot arms, then we got to mobile robots, but in both of those cases, you have to design the environment for the robots. Now we have human-centric machines. We have AI enabling general perception and context understanding, and our humanoid form factor combined with these new AI tools lets the robots do much more useful tasks in human spaces.
I love the phrase, and I'd love to get your thoughts on what it means to you and robotics. Injecting AI into robotics.
Sure.
What does that mean? Because there's a lot that goes on when you say, I'm going to inject AI into physical.
Well, like you said before, like AI has come and gone through the 80s and the 90s, and there's the AI winters and everything else, and all the things that people used to call AI, are just tools. It's this big tent of computational tools. People are trying a lot of different things. We have reinforcement learning, we have learning from demonstration, we have large language models and VLAs and all these different tools. All of them are important and useful. There is no one silver bullet, but all of these tools are this rising tide of really powerful new capabilities that allow us to make robots do things we couldn't do before.
As you look at the hardware vision, you got sensors, all kinds of telemetry, new data's coming in, you got computer vision, a lot going on. So how do you tie that together? Because now you have to stay on the front end of that innovation, which is happening very fast.
Yeah, it's true.
A lot of data coming in. I got to match my system, which is arms and legs to core brain.
Yeah.
Well, how do you look at that when you look at trying to identify the right technology match? What's some of your kind of first principle thinking around technology selection, software stack?
Well, it's about focusing on what is it our company is best at, what's our core competence, and it's the final product, it's an OEM, right? And so then there's always the make versus buy kind of questions, and like we're not going to be a specialist camera company. I don't want to be doing lenses and things like that. There are good camera companies, we should be able to buy cameras as an off-the-shelf thing. But actuators, we find there isn't. There is no way to buy the motor gear train that works for our use case. So we've had to create and build that in-house on our own, and build a lot of intellectual property, do a lot of invention to make actuators that actually allow these robots to do the kind of dynamic behaviors you want, so you can have compliant interaction with the environment and so on.
So that's a supply vacuum you're filling. Are there cases
It's just a question of, because remember, a robot is such a huge compilation of technology from so many different directions. So what pieces of the technology are things that we can reuse something that's already been developed for another industry, like chipsets, for example, and what things are we going to have to create new, because there hasn't been another industry that's needed those requirements, and that's where actuators would land.
I learned in business school, it's kind of throw a little business school theory out there. You got to focus on your core competency and outsource the non-core competency. You're seeing a lot of integration.
Yeah.
So when you start to think buy and integrate, build and integrate, how do you think about that? Because I've seen some great use cases where I say, hey, I could get a camera, but in my use case, I want to tie my software very tightly coupled with that piece of the value proposition. What's the core for you guys? How do you think about that core competency?
Our core competency is human-centric, multi-purpose robots, broadly. And robots need to go into human environments and human spaces and do human workflows and work with people, near people.
Humans with robots working together.
Humans and robots working together. So like we have to have really great safety to understand human identification and what a person is doing, how to make sure a robot is not going to fall on your foot or have a pinch point or any number of things. So that's why safety is a big core for us. It's not a lights out factory kind of industrial robot, it's a human-centric robot. And it's multi-purpose. So we have to understand multi-purpose, not general purpose. There's no such thing as general purpose, but a robot should be able to do 100 things, 500 different things. Yeah. But we start by doing the first useful thing, and then the second useful thing, right? So we're working our way up that chain, and then figuring out how to make it as versatile as possible, which is things like interchangeable tools for the manipulators, as an example.
Yeah. I love that scene in The Matrix when Neo says, upload how to Kung Fu.
Robots have Wi-Fi, right?
So this is an example of what you're saying. You can have multi-purpose that has deep specialization.
Yes.
How do you guys do that? Because then it comes up with the question of, okay, a lot of data simulation, synthetic data, primary data. How do you guys look at the data strategy there? Because data is the goal.
Yeah. Well, it is, but so think of it like the way that we've done large language models. We have an entire internet full of all the ways that humans have communicated, and we can use that to understand those patterns and recompose those patterns and create really capable robots, bots online, but it's a brain in a box, right? But now, that can't be used to control a robot. There is no source of data that tells you what motor torques you should apply on your robot, given all of your robot sensor input. So the analogy that I think a lot of people are driving is, if we just teleoperate it enough, we'll collect enough data, and we'll be able to do the same kind of thing. I don't really believe that. I think you can't possibly collect that much teleoperation data. It would take too many millions of people, too many hundreds of thousands of years to collect that volume of data. So there's like different tools that you use at each of these layers.
And you guys got to have software that's smart to know what tools to invoke.
So this is where you use a digital twin, and you use reinforcement learning in simulation to learn, and then you do a sim to real transfer, and eventually you need to have robots practice in real life too. Think of the analogy with learning to play an instrument, right? You already can see what's around you and talk to people, and that's like a language model. But now your teacher is going to say, okay, hold the instrument like this, hold the bow like that, move your fingers like this, here's what it should look like. That's like learning from demonstration. But if that's all you've got, you're not a very good violinist yet, you still need that 10,000 hours of practice. That's like reinforcement learning. The robot needs to explore its own body, its own capabilities in order to achieve, but it has to know what good is. And that's what the demonstration is for, showing it what good is. Now, that hierarchy, I think, we're seeing that emerge in AI, and it's nice that there's parallels in biology, and there's probably very good first principles reasons for that. All of these tools are continuing to improve and get better, and will for the next 100 years.
All right, so tools are out there. So I have to ask the platform question.
Sure.
A lot of talk around platforming robotics, because once you get that base use case, you have other data for either from the company or the human. How do you see data integration from maybe other systems in an organization?
Sure.
Does that
Well, I will say, once we start having a whole fleet of digit robots, right, that's incredibly valuable. And when one robot practices and learns something, they all do. So having that data is important. Having data from other robots, if they're similar to digit, you start to get into the conversation around foundation models. And it may be that information and skills learned on something that's similar transfer a bit. We'll see.
Well, you guys are doing great. I love the momentum. What's the big thing you're working on now? What's your focus? What are you optimizing for?
Well, right now, so Digit V5 is coming out at the end of this year. V5, there's a couple of key things, but the big one is safety, functional safety. So to date, the only way that any robot that is dynamically stable, that is balancing, remember they could fall on your foot, the only way you can deploy those in a warehouse is have a cage around it, have a physical barrier between people and robots. And so we've gone through this process for the past few years of figuring out how to have the robot step out of that cage so Digit can just walk into unmodified, as-built human spaces and start to do those first workflows. That is the scaling moment. When you have to put the robot in a cage,
that's a barrier.
It's a barrier, right? A literal and figurative barrier to scaling. But Digit V5 is that inflection point where these robots can get out into the world. So over the next year, we're going to start to deploy more and more of these robots outside of the work cell and get better and better on that safety front. That's really exciting.
Yeah, it's super cool. My final question is more of a personal, curious question. I envision human-centric robotics as my assistant, my aid, my augmentation, and I train it like a coworker. Where are we on the progression of human to robot training?
Sure.
Demonstration, hey, do it this way. Are we there yet? How close are we?
So there's two answers to your question. First, we do train the robots using motion capture. You put on your mocap suit and you move around and do the thing and the robot can mimic you. You use teleoperation. You teleoperate, remotely control the robot and it can learn from that. But also you can just create animation. Lots of ways you can give it an example to start from. So we're using that today and a lot of companies are using that today. But then the question of, I think that you're really asking is, I just want to say, hey robot, pick these things up and put them over there, no, do it like this, and then it learns. We are decades away from that.
Yeah.
And not just because of the technology and the capability, but also because of the safety capability.
Safety's key.
Because have this robot that can physically touch a person, hand something to you, it's such a level of intelligence and reliable decision making where you trust the robot's judgment. And if it's going to be in your home, you have to trust the robot's judgment to the point where you feel safe handing your child to a robot. And we're very, very, very far from that.
I really like how you guys are focusing on safety as the core principle, because enthusiasm's one thing, confidence is the other.
Yep.
And when you don't have the confidence, safety's huge. Just scope the order of magnitude of complexity involved in safety. All that goes into it, where you've been and come from.
On our robot, to get it out of the work cell, right? It's a bottom to top 2-year design effort that involves everything about the configuration of the leg shape to how the robot's going to fall, to having certified safe data bus and power electronics, to the array of sensors around the robot and the AI-driven human detection, and such a big effort to get to that point of being able to take the first step out of the work cell. But it's really important, we're very excited about it.
And I like how you guys nailed the first use case, but the suit, get at the workflow, get the big problems, the big rocks as they say.
Yeah, we understand that there's a very big market for our very first use case, and having these robots that are functionally safe and that they don't need a physical barrier is what allows that to scale.
Well, congratulations on the success and momentum, and we'll check in with you as the Chief Robot Officer. We're curious.
Thank you.
A lot of people really want to know how that's going to affect their lives, so great work, appreciate it. Thanks for coming on. I'm John Furrier, host of theCUBE. We're live here at the Raise Summit, day 0 at Machina. Physical AI is growing significantly, the market opportunity is expanding, a lot of use cases, real world hitting the scene, not just demos and experimentation, real world examples hitting the scene. Of course, we're doing our part to bring that to you. Thanks for watching.